Assalamualaikum, students of class 9th, that is biology and computer group. Previously, in our previous lesson, we have studied about the Rutherford atomic model, about the Niel-Bohr's atomic model, and to find out the number of electrons by using the formula 2n square. And, I hope you have learned your home task. Please don't waste your time and daily do the learning so that you will be able to understand the next topics. Now from the chapter, the another thing is, so many students ask, can we explain again and again? Some students ask how to calculate the electrons, protons and neutrons when the atom is neutral or when the atom is in the form of ion. So today I will explain once again, that is to find out the number of electrons, protons and neutrons. To find out the number of electrons, protons and neutrons. Now first, before calculating, remember 3 points. Number 1, atomic number Z. Atomic number Z. In the case of neutral atom shows number of electrons and protons. Atomic number in the case of neutral atom shows number of electrons and protons. For example, atomic number of sodium Z is equals to 11. It means electron is equals to 11 and proton 11. And you all know number of neutron. What is the formula of number of neutron? Mass number minus atomic number. Number of neutron is equals to mass number minus atomic number. Number of neutron in short, N is equals to mass number A, atomic number Z. So what is the simple formula? N is equals to A minus Z. But if the atom is in the form of ion, ion can be either positive or negative, then you cannot directly write down the number of electron from the atomic number. So learn this formula also. Number of electron is equals to atomic number minus plus electron. Number of electron is equals to atomic number minus plus electron, depending upon the nature of electron. If atom is negative, then you will add electron opposite. If if there is a negative ion, you will add the electron, and if it is a positive ion, you will subtract electron. Right? Now it will be clear from the examples. Example for neutral atom, very easy. This is the example. This is Pb. What is Pb? Pb is the element lead, but actually its symbol is taken from its Latin name plumbum. Plum P, plum B. So this P capital, B small. Atomic number is written below the symbol. It is 82. It is given in the question. Mass number is written above the symbol. That is 207. From this it is clear. Atomic number Z is equals to 82 and mass number A is equals to 207. Now because it is neutral atom, from the atomic number directly we can find out number of electron. Atomic number is Z is 82, so the number of electron is equals to 82. Number of proton is equals to 82. Number of neutron, I gave you the formula. Number of neutron is equals to mass number minus atomic number. N is equals to A minus Z. Now, what is the mass number? Mass number is 207 minus 82. N is equals to 125. So, neutron is equals to 125. Now, so what is your answer? Electron is equals to 82, proton is equals to 82 and neutron is equals to 125. Now for ion, how would you find out? How would you find out electron, proton, neutron? Suppose the ion is negative ion. That is, the ion has a negative charge. For example, chlorine. Chlorine, atomic number is 17, mass number is, atomic number is 17, mass number is 37, and the charge is minus 1 minus, that is, has a negative charge. Atomic number is 17, mass number is 37, we have written, that is Z is equals to 17, A is equals to 37. Now, from the atomic number, because there is no change in the protons, P is equals to 17. Now it's a negative ion. Now I told you the formula. What was the formula? Number of electron, atomic number, as it is negative ion. Negative ion means it has gained 1 electron. You know what in the outermost shell of chlorine there are 7 electrons. So it tries to complete 1 electron. So it will gain 1 electron. So it means for the negative ion we will add. What is the formula of number of electron for the negative ion? Atomic number plus electron gain. Atomic number plus electron gain. What is the atomic number? 17. What is the charge? That is 1 minus 1 electron. 17 plus 1 is equals to 18. Again, number of neutron, you know the formula, mass number minus atomic number, n is equals to A minus Z. That is, n is equals to mass number 37 minus 17 is equals to 20. So what is your answer? Proton 17, electron 18, and neutron is 20. Okay. Now another example is there for positive ion, for the ion that is which is positive. Consider this sodium. You know the atomic number is 11 and the mass number is 23, and it is 1 plus. It means the charge on this is 1 plus. Now atomic number, you know what is 11. Mass number is 23. A is equals to Z is equals to 11 and A is equals to 23. So number of proton directly is equals to 11. But because it is ion, positive ion, so what will be the formula? Number of electron is equals to no, because whenever the atom loses electron, it forms a positive ion. 1 plus means it has lost 1 electron. So what will be the formula for the number of electron? Atomic number minus electron released minus electron given out. Atomic number is 11. 1 plus, it means 1 minus. 11 minus 1 is equals to 10 electron. Again the number of neutrons. Now you are familiar with the formula. Number of neutron is equals to mass number minus atomic number, to n is equals to A minus Z, and n is equals to 23 minus 11 is equal to 12. So answer what will be? The electron is equals to, here you have calculated 10, proton 11, and neutron are 12. Now, in this way, we have finished all the important topics of chapter 3. Now, we will start the chapter 4, and the name of chapter 4 is Periodicity of Elements. The name of chapter is Periodicity of Elements. Today we will start the chapter 4, and the name of the chapter is Periodicity of Elements, right? And if you will understand this chapter, it will help you in your college and your second year classes also. So we have already studied this chapter, but once again, to get the clear concept, I will explain it to you once again. So you know, actually the elements are arranged in the form of periodic table in groups and periods. So it is the result of the work. It is a work of many scientists who worked on this. They arranged the elements in the different tables and forms, and finally the modern periodic table was prepared or arranged. The elements were arranged in the modern periodic table. Now, the first work or the first achievement was by Dobie-Rayner. Dobie-Rayner, actually it is known as the Dobie-Rayner law of triad. It is known as the Dobie-Rayner law of triad. Dobie-Rayner's law of triad. Simply we will call here Dobie-Rayner's triad. What do you mean by triad? Triad means group of 3. Triad means group of 3. He arranged the elements in the group of 3 according to the atomic masses. First of all, what is its law? What is his law? That is, if the elements are arranged in the group of 3, then atomic mass of the central element is arithmetical mean or the average of the atomic masses of the other 2 elements. That is the atomic masses of first and third element. If you will take the average, then its mass, then the mass of middle element is nearly equal to the atomic masses of other 2 elements. Now, you will be able to understand with the help of example. Consider the example this is the triad. That is the lithium Li, sodium Na, and potassium K. Now you know the mass of atomic mass of lithium is 7. Atomic mass of potassium is 39, right? 39. So if we will take the average or the arithmetical mean, that is by adding this 7 plus 39 divided by 2. Total is 46 upon 2 and 23, which is equal to 39. It means that is if the elements are arranged in the form of triad, then the atomic mass of central element is the arithmetical mean of the atomic masses of the other 2 elements. Consider another triad. It is the triad between chlorine, bromine, and iodine. Triad between chlorine, bromine, and iodine. Cl for chlorine, Br for bromine, and I for iodine. And the atomic mass of the sodium is 35.5 and iodine is 126.5. If we take the average, then we will add 35.5 plus 126.5 divided by 2. That actually by adding this 162 upon 2 is equals to 81, which is not almost equal, not exactly, but almost equal to the bromine, that is at 80. So in this way, but actually at that time of this Dobby-Rayner, very few elements were discovered, and it was not effective for the other elements. But this was the first attempt made by the Dobby-Rayner to arrange the elements in the form of table. Now the second law was given by the Newlands. So it's known as the Newlands law of octave. Newland's law of octave. He was the Britician. He was the industrial chemist in London, and he proposed the Newland's law of octave. And according to this law, he arranged, if the elements are arranged in increasing atomic masses, that is from smaller to bigger, then he observed that every eighth element has the properties similar to the given one or the first one. If the elements are arranged in increasing atomic masses, then every eighth element shows the properties similar to the first one or the given one. For example, he arranged the elements. His table is like this: lithium, atomic number 3, beryllium, Be, boron, B, carbon C, nitrogen N, oxygen O, fluorine F, sodium Na, Mg, magnesium, aluminium Al, silicon Si, phosphorus P, sulfur S, and chlorine Cl. I already told you the charts are also given in your class 8. Please learn the atomic number. If you will learn the atomic number, then you will be arrange the elements easily. You will be able to learn about the classification, everything. So please learn again and again the atomic numbers from 1 to 20, right? Now lithium 3. Beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9. But here the element number 10 was not included because it was not discovered at that time, and it is known as a neon. Neon was not included. So sodium 11 atomic number, magnesium 12, aluminium 13, silicon 14, phosphorus 15, sulfur 16, and chlorine 17. Okay. Now if we consider the first element, suppose this is the first count, 1, 2, 3, 4, 5, 6, 7, and 8. Sodium is the 8th element. So properties of sodium are similar to the lithium. If we will start from beryllium, what is the first element? 1, 2, 3, 4, 5, 6, 7, and 8. Magnesium is the 8th element. Its properties are similar to the magnesium. If you will consider boron, 1, 2, 3, 4, aluminium is the 8th element. In this way, different pairs can be made, that is lithium and sodium, beryllium and magnesium, then is boron and aluminium, carbon and silicon, nitrogen, phosphorus, oxygen and sulfur, and fluorine and chlorine have the similar properties. I think you now understood this law, that if the elements are arranged in the increasing atomic masses, then every eighth element has a property similar to the given one. It is like the repetition of eighth note in the music of octave. It is a very good, interesting example is given in your book, that is just like the repetition of eighth note in the music of octave. You call in Urdu the सात सुरों की दुनिया, sa re ga ma pa da ni sa. Sa is the first sur, and again when the sa comes, it is the eighth sur. So eighth note of the sur is repeated, right? Okay, but now there are the drawbacks in this this law. Noble elements were not included. That is, after the fluorine, there should be the atomic number 10, that is the neon should be included. After the chlorine, argon should be included. But these noble elements were not discovered at that time, so these were not included. So its periodic table was not in a regular arrangement. That is, these elements were not included. And heavy elements were not included. The elements with the heavier atomic masses were not included. So these were the fact, but these help other scientists to arrange the elements in a modern periodic table. Now, you have studied the Mendeleev's periodic table also. Mendeleev's arranged the elements in the increasing atomic masses. In short, we can say, what was his Mendeleev's periodic law? The physical and chemical properties of the elements are the periodic function of their atomic masses. That depends on their atomic masses. But later on, in 1914, Moseley, another scientist, discovered atomic numbers. That is, the atomic number is actually depending on the number of electrons. So So by scientific after a lot of research work, it was found out that the physical and chemical properties of element depend on their atomic number. So the modern periodic law was the physical and chemical properties of the elements are the periodic function of their atomic number, not their atomic masses. So on this basis, the modern periodic table was arranged. The model periodic table was designed, right? Now, modern periodic table. In the modern periodic table, elements are arranged in the form of periods and groups. Elements are arranged in the form of periods and groups. Now you can see these are like this. The periods are the horizontal rows. Periods are the horizontal rows from left to right. First, second, third, fourth, fifth, sixth, and seventh. Right? Now that is the from left to right, the properties changes. That is from left to right, the properties change from metallic to non-metallic. That is on the extreme left hand side, the elements are metals. On the right hand side, the elements becomes metallic. They are non-metallic. That is, they are not metal in nature. Now, in the first period is the shortest period. It contains only two elements, hydrogen and helium at the end. Hydrogen and helium. In the second period, how many elements? If you remember the atomic number starting from the 3, 4, between these are B block elements, 3, 4, 5, 6, 7, 8, 9, and 10. How many elements are there? 8. Then 10, after 10, atomic number 11, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. In the second and third period, how many elements are there? 8. How many elements are there? 8. In the fourth and fifth period, how many elements are there? There are 18. There are 18. Between these are B block 18. But just remember, in the first shortest one, 2 elements are there. In second and third, 8. In fourth and fifth, there are 18 elements. Now, the sixth period is the longest period. It contains the 32 elements. That is, there are another block of elements which is known as the lanthanides. These are the group of 14 elements. They are also included in the sixth period. They are also included in the sixth period. So actually the sixth period is the longest one, containing 32 elements. The seventh period it is incomplete. In this another group of elements is included. These are also 14 elements of the group of 14 elements, and these are known as the actinides because they start with actinium. So the seventh period is incomplete, and the elements which will be discovered later on, these will be included in the seventh period. Now these are the groups. Now about the groups. These were all the periods. Now group. The vertical columns in the periodic table are known as the groups. The vertical columns in the periodic table are known as the groups. Mainly there are 8 groups, 1 to 8. But because the difference in the properties, these A group elements are subdivided into 2 groups. That is 1A to 8A group, 1B to 8B group. 1A to 8A group and 1B to 8B group. Now, that is 1A, 2A, 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A. These are known as the main or representative elements. 1A to 8A are known as the main or representative elements because their properties are represented by the valence electrons. What are the valence electrons present in the outermost shell of atom? Now between the 2A and 3A are B block elements. Between the 2A and 3A are B block elements. B block elements are also 1B to 8B. So main groups are 8. But they are subdivided into A and B, 1B to 8B, 1A to 8A, 1B to 8B. B block elements are known as the transition elements. Why they are called as the transition elements? Because their properties shows the gradual change or transition between the two sets of elements. So the transition elements are actually the heavy metals like copper, zinc, gold, and their valencies are more than 1. For example, iron. Iron has the valency +2 as well as +3. That is a ferrous ion and ferric ion, right? So these now these 1A and 2A group elements are known as the S block elements. 3A to 8A groups are known as the P block elements, and 1b to 8b D block elements, and these lanthanides and actinides are known as the F block elements. So again, now 1a group, from the name indicates, it contains the one electron in the outermost shell, that is the 1a group. 1a group shows that the groups contain the one electron in the valence shell. 2a group shows it contains the two electrons in the outermost of the valence shell. 3a group shows it contains the 3 electrons in the valence shell, and the same way the 4a, 5a, 6a, 7a group shows that it contains the 7 electrons in the outermost shell, and 8a group shows it contains the 8 electrons in the outermost shell except the helium. So 1a group elements are commonly known as alkali metals. Why they are called as the alkali metals? Because these elements react with water to produce the alkali, like Na reacts with water to produce the sodium hydroxide, water soluble. Inshallah, we will study these groups later on one by one in detail. So now your homework is to learn these how to calculate the electrons, protons and neutrons, and to learn the different laws, that is Doberener's law with example, Newland's law of octave, and learn these the outline of this modern periodic table. Inshallah, we will continue next time. Assalamu alaikum.